Welcome to the deep dive. Today, we're going to be looking at this paper, Offline Reinforcement Learning for LLM multi-step reasoning.
Okay.
So you know how LLMs are really good at like generating text and translating languages, even writing code?
Mm-hmm.
But when it comes to like reasoning over multiple steps, like solving a word problem
Right.
or like planning a whole vacation itinerary, they kind of struggle.
Yeah, they really do.
And this paper really gets into that problem.
Yeah, it's a really significant challenge for AI research right now.
Yeah.
You know, getting LLMs to be able to reason effectively over multiple steps.
Mm.
That's kind of the key to unlocking their true potential.
Yeah.
You know.
So the paper gets into the limitations of some current training methods, like online reinforcement learning and direct preference optimization.
Mm-hmm.
So like online reinforcement learning, that's often using these algorithms like PPO.
Right.
And basically what that does is it lets the LLM learn through trial and error in a simulated environment. So it's kind of like, teaching someone to ride a bike and just letting them crash over and over again.
Yeah.
Until they figure it out.
It gets there, but
it works eventually, but it takes forever.
It takes forever, and it takes a lot of resources.
Exactly. Yeah. And then you have direct preference optimization, or DPO.
Right.
And that uses human feedback to kind of guide the LLM.
Mm-hmm. But
it has some drawbacks for multi-step reasoning.
Yeah, especially for that multi-step reasoning, because it really relies on that preference data. And a lot of times that's scarce for complex tasks.
Yeah, it's like you're judging a move in a chess game, but you don't know the outcome yet.
Right, exactly.
So you can't really say whether that one move was good or bad.
You need the full picture to really make that judgment.
And also, DPO doesn't really focus on those specific tokens.
Yeah.
Those words or symbols that are super important for getting the reasoning right.
It's looking at a very high level, rather than looking at those individual pieces that might be leading to the correct or incorrect answer.
Yeah, and that's where OREO comes in.
OREO.
Offline Reasoning Optimization.
I love that name.
Yeah.
It's very catchy.
Yeah, they definitely went for a memorable name.
Yes.
So the researchers wanted to address these limitations, and OREO is kind of what they came up with.
So this new method,
yeah,
OREO.
So it uses offline reinforcement learning.
Okay.
Which means it learns from existing data sets.
Gotcha.
So you don't need all that expensive real-time interaction.
Right, much more practical.
Yeah, so it's much more practical and accessible.
Way more accessible for researchers and developers that may not have, tons of compute at their disposal.
Exactly.
So it opens up a lot of possibilities.
And OREO also uses something called the soft Bellman equation.
Okay.
I know that sounds kind of scary.
It sounds a little intimidating.
But it's a core concept in reinforcement learning.
Okay.
And it basically helps OREO figure out how good the LLM's actions are at each step of the reasoning process.
So it's like a scoring system at each step.
Yeah.
So it knows how well it's doing.
Yeah. And this is where it gets really cool.
Okay.
So OREO doesn't just learn what actions to take.
Right.
It also learns how to evaluate those actions all at the same time.
Wow, simultaneously.
Yeah. So it develops what's called a policy and a value function at the same time.
Okay.
And this joint learning allows it to do something called credit assignment.
Okay.
Much more effectively.
So, is it able to identify specific steps that are really important for the final outcome?
Like if it was a bug in the code, it could pinpoint which line of code caused the bug.
Interesting.
Instead of just knowing that the output was wrong.
Yeah, like a granular understanding of the process.
Exactly.
Okay.
So the researchers put OREO to the test on a couple of math problem data sets.
Okay.
GSM-8K, which has grade school math problems.
Okay.
And math, which has competition level problems.
Right.
And the results were really impressive. So OREO consistently outperformed the other methods.
Wow.
Including the baseline models on both data sets.
That's great.
Yeah. And for instance, on the math data set, it achieved a 52.5% accuracy.
Okay.
Using a relatively small Quinn model with only 1.5 billion parameters.
Wow. So even smaller LLMs can achieve
Yeah.
really good performance with this method.
Pretty remarkable.
Yeah.
And they also tested OREO on the ALFWorld data set, which involves controlling agents in a simulated home environment.
So, like a virtual robot.
Yeah, like a virtual robot navigating a kitchen, trying to do different tasks.
Gotcha.
And OREO also did really well on this one.
It seems like it's performing really well across the board
Yeah.
on all these different tasks.
especially when it was faced with environments that it hadn't seen before.
So it's adaptable.
Yeah.
That's really important.
So it's not just learning to reason well, it's able to generalize that knowledge
Yeah.
to new situations.
Like if you learn to drive in one city,
Yeah.
you can drive in another city.
Exactly.
Without having to relearn everything.
Yeah. So let's kind of dig into some of the specifics of how OREO works.
Okay, yeah, let's get into the details.
One thing that I thought was interesting is it uses both successes and failures during training.
Okay.
So it's like, you're learning from your wins and your losses
Mhm.
in a game.
You learn more from your losses usually
Yeah.
than your wins.
So it's about extracting as much information as possible from the data,
Hmm.
whether it's good or bad.
Yeah.
And the paper also highlights the fact that OREO can be used iteratively,
Okay.
so you can keep training it with more data over time.
So it's constantly learning and improving.
Yeah, just like practicing a skill. The
Hmm.
more you do it, the better you get.
Yeah, like practice makes perfect.
Exactly.
Okay.
So each round of training kind of refines the LLM's reasoning abilities.
Yeah.
Makes it better at these complex problems.
It's cool that it's able to keep improving over time
Yeah.
rather than kind of hitting a ceiling so you can keep iterating.
Yeah. And keep pushing it.
So we've talked a lot about how OREO learns.
Yeah.
But what about when it's actually trying to solve a problem?
Right. How does it actually work?
Yeah, that's where it gets even more interesting.
Okay.
So that value function that we talked about,
Mhm.
it turns out it's not just a byproduct of the training process.
Oh.
It's actually a really powerful tool.
It can be used for other things?
Yeah.
Okay.
So it can be used to guide a search process,
Okay.
much like a map guides you to your destination.
So it's like a compass?
Yeah.
Okay.
And one common search technique is called beam search.
Beam search.
And that basically systematically explores all these different potential solutions to a problem.
Okay.
So it's kind of like the LLM is navigating a maze,
Gotcha.
and the value function acts as that compass.
Right. It keeps it on track.
Yeah, pointing it towards those promising paths.
Avoid those dead ends.
Yes.
Okay.
And the paper shows that using beam search with OREO's value function
Yeah.
really improves the accuracy, especially on those math reasoning tasks.
Interesting.
So for example, on GSM-AK, beam search led to an 11.4% improvement
Wow, that's a lot.
compared to just the standard method without beam search.
Okay.
So that's a big jump.
Yeah.
And the results were even better on the math dataset
Even better.
with the 17.9% improvement
Wow.
using beam search.
So the more complex the task,
Yep.
the more this seems to help.
Right.
Okay, interesting.
Now, beam search might not be applicable to those like embodied agent tasks
All right.
where the environment is changing all the time.
Yeah, because you can't really plan out a sequence of actions in those scenarios.
Yeah. It's like planning a road trip and not knowing the traffic or the road closures.
Right. You got to be able to adapt on
Yeah.
the fly.
So in those situations, ORI's value function can still play a really big role.
Okay.
So they use something called a best of K action selection strategy,
Best of K.
where the LLM samples of blue actions
Yeah.
and then chooses the one with the highest value,
Okay.
according to the value function.
It's like evaluating its options.
Yeah, it's like a mini brainstorming session,
Yeah.
picking the best idea.
And then going with that.
Yeah.
Okay.
And the results on ALFWorld showed that this strategy really helped the robot complete tasks.
Okay.
So even when you can't plan ahead,
Right.
that value function is super valuable.
Still providing guidance.
Yeah.
Okay.
So now the paper goes into the difference between what they call implicit and explicit value functions.
Okay.
So in methods like DPO, the policy model itself is kind of like an implicit value function.
Okay.
It's like the LLM's gut feeling
Gotcha.
about which actions are good or bad.
Okay.
But OREO takes a different approach,
It does.
and it actually trains a separate value function.
Okay, so it's explicit.
Yes.
Okay.
And the paper compares these two types of value functions.
Mm-hmm.
And what they found is that OREO's explicit value function
Yeah.
is generally more accurate and reliable,
That makes sense.
especially when it comes to figuring out the correct and incorrect steps in the reasoning.
Because it's trained explicitly on that,
Yeah.
whereas the other one is kind of a byproduct.
Yeah, it's like having a specialized expert versus someone who's kind of picked up some knowledge along the way.
Right. Exactly.
And to really illustrate this point,
Yeah.
the paper gives a couple of examples where the two value functions make different predictions.
Okay.
So in one case, it's a simple addition problem,
Okay.
and the explicit value function correctly flags an incorrect step
Mm-hmm.
and assigns it a low value.
It's like a seasoned detective
Yeah,
spotting a flaw.
But the implicit value function isn't as sensitive to that error.
It's like it missed the clue.
Yeah.
Okay.
And in another example with a more complex math problem,
Yeah.
the explicit value function correctly picks the right reasoning step,
Okay.
but the implicit one fails to do that.
Interesting.
So it seems like the explicit value function has a deeper understanding
Mm.
of the problem.
It's able to make those more informed decisions.
Yeah.
Okay.
So these case studies give us some really interesting insights
Yeah.
into how OREO's value function works.
It's really cool to see these comparisons
Yeah.
side by side.
And they highlight the advantages of using this explicit value function
For sure.
to guide LLM reasoning.
Yeah.
And it's this explicit value function
Yeah.
that really makes OREO so good at both offline learning
Mhm.
and test time search.
Yeah.
So it's a really powerful and versatile framework
It seems like it.
for developing these LLMs that are capable of multi-step reasoning.
Yeah. It's a big step forward.
Yeah, and remember, this is just the beginning.
Right.
There's still so much more to explore.
Yeah, we're just scratching the surface here.
When it comes to these reasoning capabilities,
For sure.
and this research opens up a whole new avenue for innovation.
Yeah, this is really exciting stuff.
Yeah.
A lot of potential here. We've been talking about OREO, and you know how it's kind of a new way to teach LLMs how to reason through multi-step problems.
Yeah, that's pretty cool.
One of the things that I think is really interesting about this is, you know how it connects to like the bigger picture of how LLMs are getting better?
Mm-hmm.
We've seen them get so good at like writing text and translating languages and even writing code.
Yeah.
But when it comes to like actually reasoning, there's still a lot of work to do.
Yeah, it's like they can do all these amazing things, but they still struggle with like the logic part sometimes.
Yeah, exactly.
And that's a big deal because without good reasoning abilities, they're kind of limited in what they can do.
Right. They can process information, but they can't really understand it.
Yeah.
And they can't really use it to solve complex problems.
I feel like they need to be able to think for themselves a little bit more.
Yeah, like make connections and figure things out.
Yeah,
So OREO is a big step in that direction.
definitely.
It's not just about making LLMs smarter, it's about making them more useful.
You're like actually being able to apply them to real world problems.
Right. Exactly.
So, I mean, imagine LLMs that could go through tons of data and find patterns and come up with hypotheses and even design experiments.
That would be incredible.
It would be like having a whole team of super smart research assistants.
Yeah. Working around the clock.
Yeah, and not just automating what we already do, but like coming up with completely new discoveries.
Yeah. Breakthroughs that we wouldn't have even thought of.
That's pretty mind-blowing.
It is.
But, okay, let's get back to the paper for a sec.
Okay.
We were talking about implicit and explicit value functions.
Right?
And the paper goes even deeper into that with some more analysis.
Okay.
They did a bunch of experiments to compare how those two types of value functions perform, focusing on this concept of advantage.
Advantage.
So advantage is this key idea in reinforcement learning.
Okay.
It's basically like how much better a particular action is compared to other possible actions
Gotcha.
at a specific point. So like if you're playing chess, the advantage of a move is how much it improves your overall position.
Compared to other moves you could have made.
Yeah.
Okay.
So the researchers compared the advantage functions that came from OREO's explicit value function and the implicit one that's kind of baked into the policy model.
Okay.
And the results were really interesting.
Yeah. What do they find?
So basically they found that the advantage function based on the explicit value function was much more accurate.
Okay.
And it gave more useful information.
So it was better at figuring out which actions were good and which ones were bad.
Yeah, especially in tricky situations.
What do you mean by tricky situations?
Like imagine the LLM is trying to solve a really hard math problem.
Okay.
It needs multiple steps.
Mm-hmm.
There might be times when several different paths look good,
Yeah.
but only one actually leads to the right answer.
It's like a maze with a bunch of false paths.
Exactly.
Okay.
So in those cases, the advantage function based on the explicit value function is more likely to find the right path.
It's a better guide.
Yeah, well, the implicit one might get confused.
Right.
Which makes sense because the explicit value function is specifically trained to evaluate how good the actions are.
Right.
But the implicit one is more like a side effect of the policy learning.
It's not its main job.
Yeah, it's like the difference between having a dedicated navigation system
Okay.
that's super accurate and just relying on your gut feeling to find your way around.
Right. Okay. That makes sense.
And the paper actually has some visuals that show these comparisons.
Oh, cool.
So you can see how the two advantage functions make different predictions in different scenarios.
That's helpful.
Yeah, it really helps understand how they work.
Yeah. Visualizations are always good.
So the paper also looks at the downsides of just relying on the policy model as an implicit value function.
Okay.
They think that something called the softmax bottleneck might be a problem.
The softmax bottleneck, what's that?
So in LLMs, the softmax function is used to turn the model's output into probabilities. So instead of just numbers, you get like percentages of how likely each output is.
Gotcha.
But that can be a bottleneck because it forces the model to pick just one best output.
Even if there are multiple good ones?
Yeah, like if you had to pick your absolute favorite song,
Right.
even though you love tons of songs.
Yeah, it's tough.
Yeah.
Right.
And that can be a problem for reasoning because it limits the LLM's ability to explore different solutions.
So the implicit value function might be held back by this bottleneck.
Yeah, making it less accurate at judging how good the actions really are.
I see.
So that's another reason why having that separate explicit value function is so helpful.
It doesn't have that same limitation.
Exactly.
So it can be more flexible. Okay.
So this whole thing about the softmax bottleneck shows how important it is to think about the design of LLMs,
Yeah.
especially when we're building them for reasoning tasks.
It's not just about making them bigger and giving them more data.
Right.
We have to think about how they work on the inside, too.
Yeah, exactly how those internal mechanisms affect their ability to reason.
That's really interesting.
And the authors of this paper definitely get that.
Yeah.
They've made some smart choices in how they designed OREO to avoid those limitations.
To make the reasoning better.
Yeah.
Okay.
Okay, so moving on from value functions,
Mm-hmm.
the paper also looks at test time search, which we touched on before.
Right.
And this is where the value function really shines.
Well, okay.
So during inference, when the LLM is actually trying to solve a problem,
Yeah.
it needs a way to explore different solutions and pick the best one.
Mm-hmm.
And test time search provides that framework.
It's like giving it a map and compass.
Yeah, exactly.
Okay.
And in OREO, the value function is that compass.
Guiding it toward the right solution.
So the paper looks at two main search techniques,
Okay.
beam search and best of K action selection.
Right.
We talked about beam search earlier.
Yeah. Can you remind me how that works?
Sure. So basically it keeps track of a bunch of candidate solutions.
Like a beam of possibilities.
Yeah. And it expands those candidates step by step.
Okay.
So at each step, it generates new candidates by adding potential next actions.
So it's exploring all the different branches.
Yeah, like a branching tree.
Okay.
And to keep things manageable, it only keeps the best candidates at each step.
So it's pruning away the bad ones.
Yeah, it's like survival of the fittest for solutions.
Right.
And in OREO, the value function is used to rank those candidates.
To decide which ones to keep.
Yeah, so it helps the algorithm focus on the most promising paths.
Avoid those dead ends.
Exactly. And the paper shows some awesome results on those math problems using beam search with OREO's value function.
Oh, yeah. What were the numbers?
So on GSM-AK, they got an 11.4% improvement in accuracy using beam search.
That's huge.
Yeah, compared to not using it.
Okay.
And on the math data set, it was even better.
Even better.
17.9% improvement.
Wow. So as the problems get harder,
Mm-hmm.
that value function becomes even more important.
Yeah, it's like the harder the maze, the more you need a good compass.
Right.
But like we said before, beam search might not be the best for those embodied agent tasks.
Right, where the environment is always changing.
Yeah, you can't plan too far ahead in those situations.
It's like trying to plan a road trip when you don't know the traffic.
Exactly. You got to be able to adapt.
Okay.
So in those cases, they use the best of K action selection strategy,
Right.
where the LLM tries out a few actions and then picks the one with the highest value.
According to the value function. So
Wow.
it's like a mini brainstorming session.
Yeah, and then picking the best idea.
Okay.
And that worked really well in the ALFWorld dataset.
So the robot was better at completing tasks.
Yeah. So even when you can't plan ahead, that value function is super useful.
It's still guiding the LLM.
Yeah.
Okay.
So another cool thing about OREO is that it can be used iteratively.
Iteratively.
Yeah, which means you can keep training it with more and more data.
Oh, so it can keep getting better.
Yeah, like you can keep refining its reasoning abilities.
That's awesome.
They tested this on the math problems, and it kept improving over multiple iterations.
So it's not just a one-time thing.
Yeah, it's like you can keep teaching it new things.
That's really exciting.
Yeah, it opens up a lot of possibilities for how we can train and use LLMs in the real world.
It's like they can keep learning and adapting as they see more data.
Exactly. All right, so we're back for the last part of our deep dive into OREO.
It's been a pretty interesting journey so far.
Yeah, I feel like we've really uncovered some fascinating stuff about how it works.
Yeah, definitely. And it's clear that it has a lot of potential.
Yeah, so we've covered like all the technical nitty-gritty,
Mm-hmm.
the value function, the search strategies.
The offline learning aspect?
Yeah. But now I want to like zoom out a little bit
Okay.
and talk about the bigger picture.
The big picture.
Yeah, like what kind of impact could OREO have on different fields and industries?
I think that's a really important question to consider, because it's not just about the technology itself.
Right.
It's about how it can actually be used to make a difference.
So like imagine scientific research, for example.
Yeah.
LLMs that can analyze huge amounts of data, find patterns.
Form hypotheses.
Yeah, even design experiments.
Like a whole team of superpowered research assistants.
It would be incredible.
It would accelerate the pace of discovery.
Yeah, and not just speeding up what we already do, but like leading to completely new breakthroughs.
Yeah, things that we haven't even thought of yet.
It's mind-blowing.
It really is.
And what about education?
Oh, yeah.
LLMs that can adapt to how different students learn.
Personalized learning.
Yeah, give them customized instruction and feedback.
Like a personal tutor for every student.
It would be amazing.
It would revolutionize education.
Make it more accessible and engaging for everyone.
Yeah, for sure.
And then there's healthcare.
Healthcare is another huge area.
LLMs that can analyze patient records, help with diagnoses, suggest treatment plans.
And all of that tailored to the individual patient.
Yeah, based on their medical history and everything.
That could really improve healthcare outcomes.
Yeah, make it more precise and effective.
It's really exciting to think about.
And those are just a few examples.
Yeah, just scratching the surface.
The possibilities are endless.
So many different fields could be transformed.
And as research keeps going, we're going to see even more incredible applications.
Yeah, for sure. This is just the beginning.
So this deep dive into OREO has been amazing.
It has.
From all the technical stuff to these big picture implications.
It's clear that AI is changing the world.
Yeah, and this research is a perfect example of that.
It's really inspiring to see what researchers are capable of.
Yeah, they're pushing the boundaries of what's possible.
And opening up a whole new future.
So thanks for joining us on this journey.
Yeah, we hope you learned something new.
And we hope you're as excited about the future of AI as we are.
Until next time, keep exploring.
And keep learning.
There's always something new to discover.